Good evening, students. Is the screen visible? Yes. Okay, good. Yes. So good evening. So in the previous class, we have completed the chapter electrochemistry. So today we are going to start with the new chapter that is from the organic chemistry. We are going to start haloalkanes and haloarenes. Okay. So we are going to start with organic chemistry. So what are haloalkanes and haloarenes? Yes. What are haloalkanes? So haloalkanes means they are called as alkyl halides, right? They are called as alkyl halides. So these are halogen derivatives, right? So these are halogen derivatives of aliphatic hydrocarbons. You know now what are hydrocarbons. So hydrocarbons are the compounds which are made up of carbon and hydrogen, right? So these are the aliphatic hydrocarbons in which one or more hydrogen atoms are replaced by halogen atoms. Okay. So here in these alkyl halides, okay, in such compounds, the halogen atoms, where they are attached to a sp3 hybridized carbon. Where they are attached to a sp3 hybridized carbon atom. So you know what is sp3 hybridized, what are sp, okay. So sp3 hybridized atom means what? When you have carbon single bond carbon. Okay, when so this the hybridization of this particular carbon is sp3 hybridized, right? So when you have a carbon with a double bonded, so this carbon, what is the hybridization? It is sp2 hybridization. And if a carbon is attached to a triple bonded carbon, then the hybridization is sp hybridization, right? So so this is the hybridization. So in alkyl halides, what is happening? The halogen atom, okay, the halogen atom is attached to a carbon atom. Okay, I'll take the carbon atom, I'll take as alkyl group. Okay, so it is represented by R. Okay, and it is attached to a sp3 hybridized carbon atoms. Fine. So this is about haloalkanes. Now, what do you mean by haloarenes? Yes, what do you mean by haloarenes? They are called as aryl halides. They are called as aryl halides. Okay. Haloalkanes are alkyl halides and haloarenes are aryl halides. So what do you mean by aryl halides? So here the halogen atom. So alkyl halides are represented by Rx. Okay. They are represented by Rx. So your R will be a alkyl group. It will be a alkyl group. Fine. Now your aryl halides. What are aryl halides? Here the halogen atom is attached to a aromatic hydrocarbons. Now what do you mean by aromatic hydrocarbons? So aromatic hydrocarbons are those which are made up of benzene rings. Okay, which are made up of benzene compounds. So benzene compounds are called as what? They're called as aromatic hydrocarbons, right? So here the halogen atom is attached to a aromatic hydrocarbons, okay, in which one or more hydrogen atoms are replaced by halogen atoms. How they are exchanged? They are exchanged by, okay. So here they are replaced. They are replaced how? They are replaced by halogen atoms. So one or more hydrogen atoms, they are replaced by halogen atoms. So in such compounds, okay, in aryl halides, okay, the halogen atom is attached to a sp2 hybridized carbon. Where it is attached to? It is attached to a sp2 hybridized carbon. So just now I have told you what is sp3 hybridized carbon, what is the meaning of sp2 hybridized carbon, and what is the meaning of sp hybridized carbon. Okay, so spt means for sp2. So how these are represented? So like this. So benzene. Okay, and I'll take a halide. So what are the examples of halide? Chlorine, bromine, iodine, fluorine. Okay, so these are your halogen atoms, right? So now when I take aryl halide, so my X will be, I'll take any halogen atom. So I can take a chlorine. Okay, so this is a chlorobenzene. So where my chlorine atom is attached, so it is attached to a carbon. Okay, and this carbon is sp2 hybridized carbon. Why? Because there is a double bond, right? You have a double bond here. So because it is attached to a double bond, right? So it is called as a sp2 hybridized carbon. Understood? Yes. Is it clear? Is the definition clear about haloalkanes and haloarenes? You can, as you know, you can, if you have any doubts, if you have any queries, if you want to answer anything, please drop your answers in the chat box. Okay. So you can drop your chat answers in the chat box. So I'll be reading them. Yes, students, is the definition clear about what are haloalkanes and what are haloarenes? चाहे जो भी सीजन हो कभी भी Yes, okay, good. So this particular chapter from organic chemistry, that is haloalkanes and haloarenes. Okay, so for your board exams, this lesson is fetching you totally 9 marks. Okay, so this particular chapter, it fetches you around 9 marks. So out of 9 marks, how the marks are distributed is uh, they are so 1 mark, 2 questions are asked. Okay, 1 mark, 2 questions. So one will be a MCQ question and one will be a fill in the blanks question. Okay, so 2 questions of 1 mark. One is a MCQ question, another is a fill in the blank question. Then 2 marks, 1 question is asked. Okay, so 2 marks, 1 question is asked, and 5 marks, that is in the long answers. Okay, in the long answers, 1 question for 5 marks. Okay, so this is the distribution of 9 marks. So how is the exam pattern? Okay, so how is the marks distributed? So these are distributed like this. Okay, 1 mark, 2 questions, 2 marks, 1 question, and 5 mark, a long question, one. Okay, for that is for 5 marks. So this 5 marks, you won't get any directly for 5 mark questions. So this is further divided by 3 plus 2. So maximum the marks you get is 3 plus 2 question. Okay, so like that. So it is further divided by 3 plus 2 question. Fine. So this is a mark distribution pattern. So moving further, so we are going to start with the MCQs. Okay, the first, as you know, for 1 mark, you are going to get a question from MCQ part and 1 mark for fill in the blank part. Okay, so we'll start with the MCQs. Okay, so this here is the first question. Which is correct order of dipole moment of CX bond of the following alkyl halides of same alkyl group? Okay, so they have asked which is the correct order of the dipole moment of CX bond of some following alkyl halides, okay, which are of the same group. So they are RF, okay, then RCl, RBr, and RI. So you have to write the correct order of dipole moment. So there are 4 options given, A, B, C, and D. So you have to arrange this particular group of alkyl halides, okay, in their correct order of dipole moment. Yes. How? So how we will explain this particular answer? How you are going to explain this particular answer, students? What do you mean by dipole moment? Firstly, yes. What do you mean by dipole moment? Yes. What do you mean by dipole moment? Yes. Don't know what is dipole moment? Did not study haloalkanes and haloarenes in your schools and colleges? Yes, students. What is dipole moment? So dipole moment is determined by how? So for a particular molecule, okay, for a particular molecule, the dipole moment, it is determined by the magnitude and direction of the individual bond dipoles within the molecule, right? So, uh, in the case of haloalkanes, okay, suppose, so it is Rx, it is represented by Rx bond, right? So here your negativity of the bond, okay, the negativity of the bond, it is determined by your which atom is attached here, right? So which atom is attached here? It is a halogen atom. So halogen atom, it is a highly electronegative atom, right? Halogen atoms are highly electronegative atom. So what they will do, it will tend to pull the electron towards itself. Okay, as it will tend to pull the electron towards itself. So there will be partial negative charge developed on the halogen atom and partial positive charge developed on the alkyl. Okay. So the electronegativity differences arises. Okay. The electronegativity differences arises between the carbon and the halogen. Okay. So this plays a very important role. So this, whatever the differences are created based upon the halogen atom as, so this plays a very important role in determining the dipole moment. So as you know, okay, as you are moving from RCl, okay, so how the atom are arranged, fluorine, chlorine, bromine, and iodine, right? So fluorine, chlorine, bromine, and iodine. So as you move from Cl to iodide, okay, that is RCl. Okay, so if I consider RF, that is alkyl halide groups. So as you are moving from chloride to iodide, the electronegativity of the halogen atom, what will happen to the electronegativity? It goes on decreases. The electronegativity, it goes on decreases as you're moving from chlorine to iodide. Okay, so the electronegativity of the halogen atom decreases, meaning what it means, that the carbon halogen bond, it becomes less polar. As you're moving down, what will happen to the polarity? It goes on, the carbon halogen bond, it becomes very less polar. So this results in a decrease in the overall dipole moment. So as a result, what will happen? There will be sudden decrease in the overall dipole moment of the molecule. Why? Because as you're moving down, what will happen to the, as we are seeing that electronegativity of the halogen atom decreases. As a result, the carbon halogen atom becomes less polar. Okay. So overall dipole moment of this molecule goes on decreasing. So therefore, it will follow the trend that RCl is greater than RF is greater than RBr is greater than Ri. Okay, so with this dipole moment decreases as the size of the halogen atom increases. So this is the reason. Okay, so this is the reason. So which is the answer? Yes, students, which is the answer? It is option number B. Okay, so RCl is greater than RF is greater than RBr is greater than Ri. So what is the reason? What is the reason? So as the dipole moment decreases down the group, the size of the halogen atom increases, right? As you go down the group, size of the halogen atom increases. So the dipole moment, it goes on decreasing. So this is the correct order. I hope the answer is uh, understood. Yes. Is it clear? Yes. So as you go down the group, what will happen to the size of the halogen atom? It goes on increases. So as the size of the halogen atom increases down the group, the dipole moment goes on decreasing. Okay, the dipole moment, it goes on decreasing. So this is the reason for your first question. Fine. So the answer is B, option number B. Moving further, second question. The compound CH2 double bond CH2Cl is. So what is the name of the compound? A, vinyl chloride, B, benzyl chloride, C, allyl chloride, and D, isopropyl chloride. Yes, the compound CH2 double bond CH2Cl is what? It is called as what? Is it a vinyl chloride, benzyl chloride, allyl chloride? Okay, Anvita has answered it as option number C. What about others? Vedvati has also answered it as option number C. Sita, Nikita has answered it as D. Yes, what about others? Okay, okay, Shushti has answered it as A. Fine. So the answer is C. Okay, the answer is C. So I'll explain you the meaning of each terms. Okay. What do you mean by vinyl chloride? Yes, students, what do you mean by vinyl chlorides? So what do you mean by vinyl chlorides? So vinyl chloride, okay. So vinyl chloride means, so here the compound in which the halogen atom, okay. So if I take, okay. So here the compound, okay. So the compound in which the halogen atom, okay. So this is the halogen atom. So halogen atom is bonded to a sp2 hybridized carbon of an CC double bond. So this is the meaning of vinyl chloride. So is the halogen atom is attached to a carbon with double bond? No. Okay. So this answer is discarded. So what is vinyl chloride? As I have said you, vinyl chloride, the halogen atom is attached to a carbon, okay, okay, which is sp2 hybridized carbon of a CC double bond. Fine. So this is wrong. Now, what do you mean by benzyl chloride? Yes, what are benzyl chloride? So in benzyl chloride, the halogen atom is bonded to a sp3 hybridized carbon atom, which is next to a halogen. Oh, sorry, next to a aromatic ring. So this is benzyl chloride. Okay. So is your halogen atom attached to a sp3 hybridized carbon, which is next to a aromatic ring? No. Right. So this is also a wrong answer. So benzyl chloride. What is benzyl chloride? Halogen atom, that is the halide halogen atom, is attached to a sp3 hybridized carbon. It is attached to a sp3 hybridized carbon, which is next to a aromatic ring. So this is also a wrong, because our halogen atom is not attached, it is attached to a sp2 hybridized carbon, sorry, sp3 hybridized carbon, but it is not next to a aromatic ring. Okay, it is not to a next to a aromatic ring. So this option is also discarded. Next, isopropyl chloride. What do you mean by isopropyl chloride? I'll write the structure of isopropyl chloride. Okay, so this is your isopropyl chloride. Fine. So this is your isopropyl chloride. So is it an example of isopropyl chloride? Yes. See? No. So this do not agree with this structure. Okay. So isopropyl chloride is also discarded. Now, what is allyl halide, students? What do you mean by allylic halide? So here in this compound, allylic halides, okay. So the halogen atom is attached to a sp2, sp3 hybridized carbon, which is next to a carbon-carbon double bond. So it is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. So is it the answer? Yes. Is it the answer? So see, your halogen atom is attached to a sp3 hybridized carbon, which is nextly attached to a carbon-carbon double bond. Yes, right. So our answer is allylic halides. Okay, so remember these definitions. Don't get confused between what is allylic halides, what are vinylic halides, what are benzyl halides. Okay, so these are the important definitions which you have to keep in mind. Okay. Is it clear? Shall we move further? Any doubts? Yes? Any doubts? If you have any doubts, please ask your doubts in the chat box. Okay. Any doubts? Shall we move further? Yes? Shall we move further? Okay, fine. Moving further, The best reagent for the preparation of RI in the presence of sodium iodide and dry acetone is. So which is the best reagent which is used for the preparation of, so I want to prepare a iodoalkane. So I have to prepare what? I have to prepare a iodoalkane in the presence of sodium iodide and dry acetone. So what reagent I'm going to use? Yes, A alkene, B 2-chloroalkane, C alkane, and D 2-fluoroalkanes. Yes, what I'm going to use for preparation, I want to prepare a iodoalkane, okay, in the presence of sodium iodide and dry acetone. So what should be my starting reactant? What reactant should I take for preparation of iodoalkanes? Yes, which are the best methods for preparation of your iodoalkanes? Yes. So from which method I can prepare? Okay, I've got the answers. So Nikita has answered it as C. Anvita has answered it as B. Vedvati has answered it as B. Srushti has answered as C. Varsha has answered it as B. Sita has answered it as C. Okay. Can you tell me the name reaction from where we can prepare iodoalkenes? You have studied this, right? So which is the best name reaction from which you can prepare your iodoalkane? Yes, do you know this? Which is the best method? Yes, Vedvati and one more. This is Sita. Yes, both have answered it right. It is Finkelstein reaction. Okay, so this is a name reaction, very important name reaction. Please mark this as very important. Finkelstein reaction. So this can be a question for 2 marks. Explain Finkelstein reaction with an example. Please note this down. Explain Finkelstein reaction with an example. Okay. So what is Finkelstein reaction? Alkyl chlorides. Okay. Alkyl chlorides or bromides. When you react it with sodium iodide in the presence of dry acetone, you get alkyl iodides. So you can prepare your iodoalkane. So I want to prepare a iodoalkane. So here, which is the reagent? It is 2-chloroalkane. So if I take 2-chloroalkane, so suppose if I take 2-chloroalkane, so if I take example, so I'll take an example only here directly. So the answer is B. Okay, so whenever you want to prepare iodoalkanes, you can prepare your iodoalkanes from chloroalkanes or bromides. Okay, alkyl chlorides or bromides, and in the presence of sodium iodide in dry acetone, you can prepare your iodoalkane. So this is known as Finkelstein reaction. So study an example. So I can give you example as CH3, CH2, Cl. Okay. So 2-chloroalkane. So I'll take the same thing that only. Okay, 2-chloroalkane. So CH3, CH, CH3. So 2-chloroalkane, when you react it with sodium iodide in the presence of dry acetone. Okay, what product you will get? You will get CH3, CHI plus CH3 plus NaCl. Okay, so this is the reaction. So I have taken 2-chloropropane. Okay, I've taken, so they have mentioned it as alkane. So I've taken a chloropropane. So I got what? 2-iodopropane. I got 2-iodopropane. Is it clear? Fine. Moving further. So mark this as very important Finkelstein reaction. So there can be a question either in this way or it will be a direct. So this was an indirect question, right? So this was an indirect question. So you can the question can be asked directly also or indirectly also. So you can expect it in both the ways. Next question. Chlorobenzene, when it reacts with magnesium in dry ether to give a compound A. So I'll write the structure of chlorobenzene. Okay, so this is a chlorobenzene. So chlorobenzene is reacting with magnesium in the presence of dry ether. Okay, in the presence of dry ether. Yes, what it will be? What will be the compound A? Yes, students, answer. What will be the compound A here? when chlorobenzene will react with magnesium in the presence of dry ether? Mm, yes, it is B. Good. Srishti, Sita, Vedvati, Nikita have answered it right. Yes, it is B. Okay. It is C6H6, sorry, C6H5 MgCl. So the answer will be, so like this. Okay. So C6H5 MgCl. So it is RMgX, right? So this is a reaction called Grignard reagent. Okay, we are forming the Grignard reagent, right? So this is Rx. So how is this reaction? Rx plus Mg, sorry, Rx plus Mg gives you RMgX. Okay, so this is our reaction. Is it right? So this is a Grignard reaction. Okay, this is a Grignard reaction. You're forming a Grignard reagent. So our option is option number B. Fine. Moving further, question number fifth one. The order of reactivity of the following alkyl halides in SN2 reaction is. So what is the order of reactivity of the following alkyl halides in SN2 reaction? Remember, what is SN1? What is SN1? Substitution, nucleophilic, unimolecular. Okay. Here, the rate of the reaction depends on only one. Okay, that is substrate. Here there are two-step mechanism. So this is a two-step mechanism. Okay, and here it goes in the process of carbocation. So here the carbocation formation takes place. Here it depends upon only substrate. Okay, in SN1, I'm talking about SN1. How is the stability? Tertiary is more stable, then secondary, and then the primary. Now, when we are talking about SN2, what is SN2 mechanism? It is substitution, nucleophilic, bimolecular. Okay, bimolecular, the rate of the reaction, okay, the rate of the reaction depends upon, so there is only, depends upon two, that is substrate and nucleophile. Substrate and nucleophile. Okay, so here it is a one-step mechanism. It is a one-step mechanism which goes via transition step. It goes via a transition step. The rate, sorry, the order of reactivity is primary is more stable than secondary is more stable than tertiary. Okay, primary is more stable than secondary is more stable than tertiary. Is it right? Okay, so now you can see the other two options also. Just a second. Okay, now you can see. Okay, now see the other two options. Now you can answer me. Okay, already the answers are out. Sita, Shushti, Vedvati, Sita. Okay, they have answered it right. Yes, it is. Primary is greater than secondary is greater than tertiary. Okay, I'm talking about SN2, not about SN1. In SN1, tertiary is more stable than secondary and then primary. Remember this, SN1 is two-step mechanism, SN2 is one-step mechanism. In SN1, the rate of the reaction, it depends upon the concentration of only substrate. And in SN2, the rate of the reaction depends upon the concentration of substrate and nucleophile. The SN1 reaction, the rate of order of reactivity is tertiary is more stable than secondary and then primary, and SN2 primary is more stable then secondary and then tertiary. So which is our correct answer? It is B. Yes, the answers are right. Good. Okay, so answer is B. So primary is more stable then secondary and then tertiary. Next question. Reagent used for the following conversion is, so which is the just a second. Okay, leave this question. Go for the next question. Okay, seventh one. Go for the seventh one. Vicinal dihalide is, what is vicinal dihalide? Dichloromethane, B 1,2-dichloroethane, C vinyl chloride, and D allyl chloride. Yes, what is vicinal dihalide? First of all, what are vicinal dihalides? Yes, students, what do you mean by vicinal dihalides? What are vicinal dihalides? Can you tell me what are vicinal dihalides? Yes, okay, I've got answer. Fine. So vicinal dihalides, halogen atoms are attached to the adjacent carbon atoms. Okay, what do you mean by that? Vicinal dihalides. Can I give you example? Then you'll come to know. Okay, so vicinal dihalides means what? So in this, the compounds in which halogen atoms are attached to adjacent carbon atoms. Okay, so here the halogen atoms are attached to adjacent carbon atoms. So suppose I take a ethane. So like this. So the halogen atoms are what is that? Are attached to adjacent carbon atoms. Okay, and suppose the halogen atom is attached to the same carbon atom, then they are called as what? Do you know that? So if the on the same carbon atom, if two halogen atoms are attached, X represents your halogen. Okay, don't get confused. X represents your halogen. I can take it as Cl and Cl. So if two halogen atoms are attached to the same carbon, what they are called as? Yes, students, what they are called as? Can anybody answer? Yes, somebody. No. Yes, what they're called as if the halogen atoms are attached to same carbon atoms. Yes, yes, Nikita has answered it right. They are called as geminal dihalides. Okay, they are called as geminal dihalides. Remember these words, okay? They are called as geminal. They are called as geminal dihalides. So if the halogen atoms are attached to the same carbon atom, they are called as geminal. And if the halogen atoms are attached to the adjacent carbon atoms, they are called as vicinal. So can you tell me the answer now? It is B. Okay, it is B. 1,2-dichloroethane. So 1,2-dichloroethane. So like this. So this is ethane. So at one position and two position, you have your chloro groups. So it is 1,2-dichloroethane. So one dichloromethane. Dichloromethane is like this. Dichloromethane. Okay. So on the same carbon atom. So this is wrong. Okay. Dichloromethane, this is a structure. So on the same carbon atom, two halogen atoms. So these are geminal dihalides. Okay. So this is the example of geminal. So 1,2-dichloroethane. So this is a structure. So on the adjacent carbon, two halogen atoms are attached. Then what is allyl halides? Yes, we have seen just now. What are allyl halides? Right. What are allyl halides? Allyl halides means okay, so the halogen atom is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. So this is also wrong. Okay. Then what is vinyl chlorides? Vinyl, here the halogen atom is attached to the sp2 hybridized carbon, which is next to a carbon-carbon double bond. So this is also wrong. So the correct answer is B. The correct answer is B. Remember, vicinal means the halogen atoms are attached adjacent to the carbon atoms, and geminal means the halogen atoms are attached to the same carbon atom. Okay, fine. Moving further, next question. The reaction of alkyl chlorides with alcoholic KOH is an example of the reaction of alkyl chloride. So I'll take alkyl chlorides, I'll take it as RX. Okay. Alkyl chloride, I'll take it as RX or I'll take it as RCl when you react it with alcoholic KOH. So what is the example? Is it a substitution reaction? B, elimination reaction? C, addition reaction? And D, condensation reaction? Yes? Okay, Vedvati has answered it as A. Others? Okay, A. Varsha has answered it as C. Alkyl chlorides with alcoholic KOH. The reaction of alkyl chlorides with alcoholic KOH is an example of A, substitution reaction, B, elimination reaction, C, addition reaction, and D, condensation reaction. So this is a example of elimination reaction. Okay. So this is a example of elimination reaction. So your OH will abstract the carbon from this alkyl group. Okay. And it forms, so if I take your example like this, so CH2Br, if I react it with alcoholic KOH. So KOH means this OH is there. So this OH will abstract this hydrogen. Okay, this will take this hydrogen. So in turn, it will undergo a beta elimination and it will forms a carbon-carbon double bond. Plus it forms HBr. Okay, HBr is eliminated. So this is an example of elimination reaction. That is a beta elimination reaction. Okay, because from your beta carbon, so this is your alpha hydrogen, this is your beta hydrogen. Okay, so this is called your alpha hydrogen because next to the halide group, next to the halogen group, this is your beta, this is your alpha hydrogen and this is your beta hydrogen. So it is called as beta elimination. So from your beta carbon, your hydrogen is eliminated. Fine. So this OH will abstract this hydrogen and this in turn will take your bromide along with it. So this is example of elimination reaction. Moving further, in vinylic halides, the halogen atom is attached to. Yes, now we have discussed what is vinylic halide. So I want the answer. In vinylic halides, the halogen atom is attached to A, sp3 hybridized carbon, B, sp2, C, sp, and D, dsp2. Yes. Okay, good. Vedvati Sangeeta has answered it right. It is sp2. Okay, it is sp2. So I have told the definitions now to many times. So I hope, yes, Srushti, Sita, Nikita, yes, good. Okay. So we'll move further. Okay, vinylic halides, we have explained it a lot many times. So we'll cover the next points. Next question. Aryl halides acquire CCl double bond character. It is due to A, inductive effect, B, resonance effect. Sorry. Aryl halides. Aryl halides acquires CCl double bond character is due to inductive effect, resonance effect, electromeric effect, hyperconjugation. Yes, students? Okay. It is due to. So this is a very important question. Okay. This question is asked on aryl halides. I'll just tell you the question. Just a second. The partial double bond character. Yes, it is due to resonance effect. Okay. It is due to what? It is due to resonance effect. Fine. So this you have studied. Yes. Vedvati, all have answered it right. It is due to resonance effect. So, as you know from resonance structures, okay, from resonance structure, what will happen? The CCl bond, as it has a partial double bond character. So, as there is a cleavage, as there is a cleavage in the cleavage in the haloarenes is very difficult. Okay, the cleavage, the bond cleavage. So you cannot break the bond in the haloarenes. Okay. So because of this, it is less reactive towards a nucleophilic substitution reaction. So when you write the resonance structures, you will come to know. So it is due to resonance effect. Next question. SN1 reaction of optically active alkyl halides leads to. Yes. So when we talk about SN1 reaction, how the reaction proceeds, whether it proceeds with retention of configuration, B racemization, C inversion of configuration, and D none of this. Yes, how the reaction will proceed, whether it will be retention, racemization, inversion, or none of this. What do you mean by racemization, students? What do you mean by racemization? Racemization means what? When you have equal amounts of dextro and levorotatory substances. Okay. So this will get cancelled. Okay. With the equal, as you have equimolar mixture of dextro and levorotatory substances, the two substances, okay, as they are in equimolar proportion, they will get cancelled with each other. Okay, so it will lead to racemization. What do you mean by retention? What do you mean by retention? Retention means what? Now suppose if I give you like this. Okay, C, A, B, C, and X. So this will, when it undergoes a reaction, still the configuration will remain the same. Only there will be change in this, replacement in this. Okay, so this is called as retention. Okay, so retention means what? The stereo center. Okay, the reaction, there will be no bond to the, that is the stereo center, there will be no bond will be broken. Okay, so the reaction and the product will have the same configuration. The reaction will proceed in the same retention of configuration. Fine. Next is inversion. What do you mean by inversion? Inversion means what? There will be breaking of bond. Means what? Suppose if I take CX, then you know, not CX, I'll take it as CA, B, C, and X. So when this will undergo a reaction, there will be like this. Okay, so this is called as inversion. So what is happening here? You can see that here, what will happen here? You can see there is a bond. Okay, so breaking of bond takes place near the stereo center. Okay, there is a change in configuration. You can observe the change in configuration. So this is called as inversion. So SN1 of optically active alkyl halide. So what it leads to? Retention, racemization, or inversion? It leads to racemization. Yes. So there will be both. Okay, 50% retention and 50% retention and 50% inversion. Okay, so it leads to racemization. So when you are studying the stereochemical aspects of SN1 reaction, so this should be kept in mind. Fine. Now moving further. Primary alkyl halides prefer to undergo. So primary alkyl halide. Suppose I have a primary alkyl halide. I take this primary alkyl halide. I take a methyl bromide. Okay. So what it will undergo? SN1 reaction, SN2 reaction, addition reaction, or condensation reaction. Yes. When you have a SN, that is a primary alkyl halide. Remember the reactivity. If you have a primary alkyl halide, okay, what it will undergo? SN1 reaction, SN2 addition or condensation. Yes, it will undergo. Read the answer properly. Sorry, read the options properly. Vedvati, Nikita have answered it right. Okay, so it is SN2. Okay, it is SN2. So whenever you have primary alkyl halides, alkyl halides will undergo SN2 mechanism because the stability is SN1 is greater than SN2 is greater than that is sorry SN1, that is primary is greater than secondary is greater than tertiary. And whenever you have a tertiary alkyl halide, suppose I have this are called as tertiary alkyl halide. Okay, so if I have a tertiary alkyl halides, so when you have a tertiary alkyl halides, they will undergo SN1 mechanism. Okay, so tertiary alkyl halides are more stable than secondary and then primary in case of SN1 mechanism. And whenever you have primary alkyl halides, so it will undergo SN2 mechanism. So which is the correct answer? It is option number B. Okay, it is option B. Next question. The optical inactivity of racemic mixture is because of, so the optical inactivity of racemic mixture is because of A, molecular dissymmetry, B, internal compensation, C, presence of chirality, and D, external compensation. The molecular or optical inactivity of racemic mixture, it is due to external compensation. Okay, remember this. It is due to external compensation. Now, next question. Which of the following has the highest boiling point? Okay. Which of the following will have a highest boiling point? N-pentyl chloride, B, secondary pentyl chloride, C, isopentyl chloride, and D, neopentyl chloride. Yes. How the molecular, this boiling point increases? When the boiling point increases, remember, okay, as you move from lower alkanes to higher alkanes, or you can take alkyl halides, okay, because we are taking about when you're moving from lower alkyl halides to higher alkyl halides, what will happen? The molecular mass increases. What will happen? The molecular mass increases. So as the molecular mass increases, boiling point also increases. This is one thing. Another thing you have to remember that whenever branching is there, okay, whenever now in case of N-pentyl means it is a straight compound, okay, with 5 carbon atoms. 5. Okay, N-pentyl means 5 carbon. Secondary means what? It will have a secondary this. Okay, secondary this. So whenever you have a branching, so as branching increases, what will happen to the area? It goes on decreasing. So boiling points also decreases. Okay. So remember, so whenever you have a straight chain compound will have a higher boiling point. So N-pentyl chloride. Okay, N-pentyl chloride. So when we are talking about boiling point, okay, so this is the things you need to remember. Is it correct? Is it fine? So moving further, the most reactive compound towards nucleophilic substitution in the following is, yes, which is the most reactive compound towards the nucleophilic substitution in the following reaction is? Yes, the more the most the most reactive compound towards nucleophilic substitution in the following is ethyl bromide, ethyl chloride, ethyl iodide, or ethyl fluoride. Yes. What is the answer? Okay, most of you have answered it as B. Okay, so remember that whenever, okay, so better the living group, faster is the nucleophilic substitution reaction. Okay, so the stability of the living group is iodine is greater than bromine, is greater than chlorine, is greater than fluorine. Okay, fluoride ion. So the which will be the, so better the living group, okay, faster is the nucleophilic substitution reaction. Remember this. So which will be the answer now? Now at least. Yes, it is option number C. Okay, it is ethyl iodide. So remember this, better the living group, faster is the nucleophilic substitution reaction. Okay, as you move down the group, what will happen? The size of the, what is that? Halogen atom increases. Okay, so whatever the incoming, this is there, what incoming nucleophile should be there? It should be stronger than the leaving group. So always the iodo group, okay, that is iodo will be stronger than your bromine, chlorine, and iodine. So this is the order of reactivity. Okay. Next question. Conversion of iodobenzene to ethyl benzene using sodium in the presence of dry ether is A. Woods reaction, B. Woods fatigue reaction, C. Fatigue reaction, and D. Ullmann reaction. Yes. Conversion of iodobenzene to ethyl benzene. Conversion of iodobenzene to ethyl benzene. See here, iodobenzene is this. Iodobenzene in the presence of sodium and dry ether. Okay, giving you what? Ethyl benzene. So ethyl benzene is like this, C2H5. Okay, how this group will come? So this is a aryl halide. Okay, I should take a alkyl halide. So I will take C2H5I. Okay, if I take alkyl halide, so this is a alkyl halide, this is a aryl. So one molecule of alkyl halide, one molecule of aryl halide. So when it reacts, it forms your alkyl aryl halide. Okay, it forms a alkyl halide, alkyl halide, aryl halide. Okay, and sodium iodide. Okay, so this is the byproduct form. So this is a Woods fatigue reaction. It is what? It is a Woods fatigue reaction. Fine. What is Wurtz-Fittig reaction? You are taking one alkyl halide and one molecule of aryl halide. Right. What I'm taking? I'm taking one molecule of alkyl halide and one molecule of aryl halide. So what is happening here? See here. I've taken ethyl iodide. You can see here. Okay, ethyl iodide and one is iodobenzene. Okay. So what is happening here? This ethyl reacts with your benzene. Okay, and this Na combines with this two iodides. Okay, so it forms N2NaI plus your alkyl aryl halide. Okay, alkyl, that is ethyl benzene. It's fine. So this is your Wurtz-Fittig reaction. So in the next class, we are going to see these are very important. Wurtz reaction, what is Fittig reaction, and what is Wurtz-Fittig reaction. Very, 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 very important. Okay. And Finkelstein reaction. So study that. In the next class, we are going to discuss on that. Is it clear? Yes, students, is it clear? Whatever has been taught, is it clear? Okay. Any doubts? So we have left with fill in the blanks, then 2 marks question and 5 marks question. So this we will do it in the next class. Okay. So if you have any doubts, you can ask me. Okay. Did you understand today's session? Yes. Okay, good. Fine. So these were the things which were to be covered today. So in the next class, we are going to see the MCQs. Okay. We are going to see the MCQs followed by sorry, not MCQs, fill in the blanks, followed by 2 marks question and 5 marks question. Okay. So fine. So we'll meet in the next class. Okay. So till then, try to read the other concepts so that it will be very easy for you also, so that you will be answering. We should have an interaction during our sessions. Okay. So just go through just brush up the things what has been taught in your classes. Okay. So that for the next time, it will be very good for you. So I'll end the session here. So we'll meet in the next class. Thank you. Have a good day, students.